Hello, 7th graders. Welcome to lesson 8-2. We're really only doing this in one day, so you get rid of the day one if you want to. I can solve two-step equations using the vertical method. Really just solving two-step equations more than anything. I'm only going to teach you one method because at this point, that's the one that's going to be best suited for you. So we're going to start by going in on page 422 in our textbook. I did hand out this sheet to you. This would be something I want you to keep in handy to review. Solving one-step equations, you do inverse operations. So when you have a number plus 12 equals 10, we say what number plus 12 equals 10? So we would subtract that 12. We would subtract that 12 from both sides. It's not going to work out very well. And we'd end up with m is equal to -2, for example. So that's something to use as a review. Use this as a little practice as well to get rid of a fraction multiplied by the what you do in this case. I'm going to have to use the mouse here. You would do the inverse operation of dividing by 2/3, but dividing by 2/3 is the same as multiplying by 3/2 on both sides. So you can multiply by the reciprocal is what you call that. So you would say instead you would multiply by the, you would multiply by the reciprocal. So again, review. Come back to this as extra practice when you are done as well, and we'll go over a little bit of it. But solving two-step equations, again, this is just we're doing it in one day today. You can call this reverse engineering. A two-step equation contains two operations. In the equation, 3x plus 1 equals 7. X is actually multiplied by 3, and then 1 is added to it to get to 7. So say you had a number, x would be a number of cans of dog food, multiplied by, or 3 cans of dog food for x amount of cost, plus $1 equals 7 or something. To solve this, you undo each operation in the reverse order. So if the last thing you did was add 1, the first thing you're going to undo is subtracting 1. Solve the two-step equation. So to do this, you first write the equation. Then you're going to use subtraction property of equality to show that you can subtract 1 from both sides. So you're going to do -1 and -1 from both sides, which is then going to equal just 3x equals 6. A little bit messy. From there, you use the division property of equality, which means you're going to divide by 3 on both sides because you have a 3x here. And you divide by 3 to get x alone because 3 divided by 3 is 1, leaving just x. 6 divided by 3 happens to be 2, and what we call that is simplifying. X equals 2 is simplifying. You always want to check your solution. How you check your solution is that you plug in your solution of 2 into the original equation. So we do 3 times the value of x, which we know is 2, plus 1 equals 7. And so when you work this out, if 2 is actually the correct solution, you should end up with both sides remaining equal. And we do. We end up with the reflexive property of 7 equals 7, which means that our solution of 2x equals 2 was true. In a nutshell, that's what we're doing today. So giving this one a try, solving 25 equals 1/4 of a number minus 3. So I see that what happened to this number was it was multiplied by 1/4, and then 3 was taken away, and you ended up at 25. So what you can do, the first thing you should undo is that subtraction. Order of operations says that what undoes the inverse of subtraction is addition. So I'm going to add 3 to both sides. And so I end up with 28 on this side is equal to 1/4 of a certain number. To undo fractions, like we just said in the beginning, this is like dividing by 1/4, but we know that dividing fractions is easy as pie. You flip the number and multiply, because we know 4 times 4 is 4, 4 times 1 is 4, 4 times 1 is 4, and you can cross cancel, and that's really just going to be 1 over 1. So we just have a single 1n left, which is what we want. So we do the same thing over here, multiply by 4 over 1, or just 4. And when we do that, you're going to do 28 times 4. Say you don't have a calculator, you can do 8 times 4 is 32, and 20 times 4, which is 80. Add those together for 112 is equal to n. Checking your solution again, you can plug it in. So you're going to do 25 is equal to 1/4 of 112 minus 3. Again, I'm sorry for the writing. I'm trying to get used to this thing. 25 is then equal to 28. Use your calculator if you need to, or cross cancel, minus 3. And so 25 equals 25. So my solution of n equals 112 is correct. Here's 3 to give a try using inverse operations, reverse engineering, if you will. So you can give those a try for good measure. First one, I see that I'm multiplying x times 3 and then adding 2. Since adding 2 is the last thing I did, it's the first thing I undo. To keep things equal, a lot of people do these train tracks. Make sure you're remembering to try to keep everything equal. 2 minus 2 is 0. So I'm left with 3x on this side is equal to 18. We undo multiplication with division. 3 divided by 3 is 1x. 18 divided by 3 is 6. And again, check your solution. So you may do 3 times 6 plus 2 should equal 20. Order of operations in the correct way now. 18 plus 2 is equal to 20. Since this side does equal the other side, then my solution is correct. Same thing on the other side. The inverse operations, notice my variable's in a different spot now. It's going to be okay. So again, I'm multiply n times 2 and add 5 if I was doing regular operations. So I undo by subtracting 5 on both sides. You have to make it equality. Everything's equal. So that leaves me with just 2n on this side is equal to, add the opposite, that's a negative 6 over here, divide by 2. So you have n is equal to a negative 3. Plug it in to check. 5 plus 2 times negative 3 should equal negative 1. 5 plus a negative 6 should equal negative 1. And it turns out 5 plus negative 6 is negative 1. So negative 1 equals negative 1. I don't know why that turned black suddenly, but that means that my solution is correct. Same thing over here. We have negative 1 is equal to 1/2 of a times, or plus 9. So we have to undo. We're going to subtract 9 first. Maybe make my train tracks first. So I subtract 9. Oopsie. And so I add the opposite. That's really negative 1 plus a negative 9, which is negative 10, is equal to 1/2 of what number? To undo multiplying by 1/2, you could divide by 1/2, which is the same as multiplying by the reciprocal of 2 over 1. I'm going to show this. This is getting a little bit messy for me. I'm going to rewrite this part. So we had negative 10 is equal to that 1/2 times a. 1/2, notice, remember, 1/2 times 2, half of 2, happens to just be 1. So we cross multiply, cross cancels. We do the same thing on the other side, multiply by 2. So we get negative 20 is equal to a. You can double check your work. So we double check and we do -1 is equal to 1/2 times -20 plus 9. So we get -1 is equal to -10 plus 9. -1 is equal to -1. So our solution sure is right. So solving equations with negative exponents, what that means is we have a -3 here. So again, you're going to rewrite it. What you have to do is do the chop minus first. So you remember that that's a negative. A lot of people right here are just going to say, oh, I need to add 6 because I see a subtraction sign. But you're not actually subtracting 6 here. So you need to see what you are doing is you're really just adding a -3x. So now we see that we need to do -6 on both sides. And we have to bring down that -3. So that's a -3x is equal to 15. Divide by -3 on both sides. So we get x is equal to a positive divided by a negative is going to be at -5. This is where the checking solution really comes in handy when negatives are involved. Because if you were to plug in a 5, you would not end up with the right answer. So if I plug, I'm going to show you, say I would have ended up with x equals 5, which is wrong, and I tried to plug it in. I get 6 minus 3 times 5 is -21. I'd get 6 minus 15 is -21, but I actually get a -9 is equal to -21, which is not true, meaning that solution is not right. So should I plug in the correct solution of -5, I do 6 minus 3 times -5 is equal to -21. So then I get 6, a negative times a negative is a positive 15. Oh, that's a positive 21 over here. Either way. Is equal to 21. And 21 is equal to 21. It should have been positive over here, but either way, it wouldn't have ended up correct. But this was a positive 21 in the start. So 21 does equal 21, which makes my solution of -5 work to make it true. So give some of these a try. We'll give some a try. So again, I'm going to add the opposite to see on some of those that I know what I'm doing. So for this one, now I see that I'm actually adding 10. So I still need to subtract 10 from both sides. So I'm left with a -2/3 p equals 42. So to undo and divide, I actually multiply by the reciprocal. So multiply, flip it, reciprocal, Miss Simmer's favorite word. And they cross cancel with leaving just 1 p. Going to multiply by -2/3 over here. I'm running out of room. I can cross cancel. Put this over 1. This is the same as 2 goes into 2 once. 2 goes into 42 21 times. So I'm actually left with 21 times -3, which would be a -63. And plug that back into check. Over here, I'm going to undo addition with subtraction. Add the opposite. That's a -21 is equal to -3x. Divide by -3. Negative over negative is a positive, and I would rewrite my answer variable first. Plug it back into check. We'll go over them again. This is division, so that has to come second. The last thing I did was subtract, so the first thing I undo is add. So I have 2n divided by -3 is equal to -16, is that right? And then I multiply by -3, cross cancel. And so I have n is equal to a negative times a negative is going to be a positive. And it's going to be a positive 48. And again, plug it back into check, it's right. Combining like terms first. Sometimes you're going to have to combine like terms before you can solve because you're looking for one single variable. So when you do that, you just have to combine your like terms. 2n plus 1n, or -2y plus 1y is just a -1y. And so you simplify before by combining like terms before you can solve. Then you go ahead and get your variable alone. So I add 5. And I get negative y is equal to 16. I don't want a negative y though. So this is really like a negative 1y. To undo a negative 1, you either multiply or divide by a negative 1, because a negative times a negative is a positive. Same thing on the other side. So you end up with negative 16. And you can plug it into the original to double check as well. So make sure you're doing those things. Last few, again, combined terms. That's a 1x plus 4x. Pause me before if you want to try it and then come back. You get 5x is equal to 45. Inverse of multiplication is division. So you see x is equal to 9. Plug it back in the check. Combine like terms. Negative 1a plus 2a. It's like 2 minus 1. So it's 10 is equal to just a plus 13. Subtract 13. Add the opposite. That's a positive plus a negative. It's messy. And you get a negative 3 is equal to a, or a is equal to negative 3. That was kind of messy, so I'm going to fix that. That was minus 13, which is plus a negative. So rewatch, watch somebody else's. A lot of information there, so make sure you're going back, rechecking. Main thing to remember, inverse operations when solving. Best of luck.